Alright, in this problem we're trying to find the speed that a car will travel, and we know its tire has a radius of 0.32 meters, and that this tire is going to spin at 840 revolutions per minute. And so we want to find out how fast the car is going to go. So this is really asking how fast, if you had like something stuck on one end of the tire, how fast this is going around in the circle, because that's on the road. That essentially is going to be, however fast this is going here, that's how fast it's going to move on the road. So in this situation, it's velocity, and it really comes down to, like most velocity things, distance over time. So at the end of this circle, what distance is being traveled over what period of time? And this right here, 840 revolutions per minute, is in fact a sort of velocity. The revolutions represents the distance, and the minutes are the time. But that's not very useful to us. We usually want a unit like meters per second. So to figure that out, we have to first find out, okay, well, what is the distance of one revolution? So a revolution is a complete time around the circle. So one revolution, we're going to use the formula for circumference, which is 2 pi r for the circle. So one revolution then for the circle is going to be 2 pi times 0.32. And so I'll plug that in, and so 2 pi times 0.32, I get that one revolution is 2.01 meters. Alright, so now I want to find out how fast this is going. I have 840 revolutions. So 840 revolutions, and one revolution is 2.01 meters, so I find out what that distance is. So 840 times 2.01, and that is 1688.4 meters. So that right there is my distance. And now my time, it's in minutes, so if I want meters per minute, I can divide by 1 and get that. But typically I'm going to want seconds. So I know that 1 minute, and this I can just kind of do, the time is 60 seconds. And if it was more than 1 minute, then I could adjust accordingly. So now the speed of the car is going to be distance over time. So I'm going to say 1688.4 meters over 60 seconds, and that is going to give me my time in meters per second. So when I do that, I get 28.14 meters per second. I'll probably round this to 28.1 meters per second. Probably technically should be 28 if I pay attention to sig figs, but I'll just call this sufficient. So that is the speed of the car, and that's, again, that's how fast, if you were on the edge of the tire, this is how fast it's going around in a circle. If the tire had a bigger radius and it was spinning at the same rate, so if it was a bigger tire and it was spinning at the same revolutions, you would end up with a larger revolution, a larger distance. So a bigger tire spinning at the same rate, at least revolution-wise, would actually go faster. The car would go faster, assuming it could maintain the same RPMs. But anyway, that's basically how you convert what we call radial velocity into tangential velocity. And that's it. So until next time, I am Derek Genova. Have a delightful day.